Now let's solve the rational equation 4 over x plus 3 over x squared is equal to -1. The -1 is not a fraction, so I'm going to put it over 1 just to keep it consistent so everything's written as a fraction. And then we need to find our least common denominator. If I try to break down what we have for each denominator, well, the first one's just x. X squared means x times x. And then the other one is just a 1, and we don't really have to do anything with a denominator of 1. And in our least common denominator, we're going to need an x, and that covers, let's say, the 1x that we have in each denominator. But we're also going to need another one, and that's because for the denominator of x squared, in order to be a least common denominator, that means you have to have two x's in there, x times x. Our least common denominator here overall is x squared. And now we need to do the multiplication in order to get each denominator to be an x squared. The 4 over x we can multiply by x over x, because if we multiply on the denominator, that would give us x squared, which is what we want. 3 over x squared already has a denominator of x squared, so we don't have to do any multiplication there. And the -1 we're going to multiply by x squared over x squared. And then I'm just going to rewrite the equation. And what's going to be in the denominator for each one is x squared, which is exactly what I wanted to happen. So 4x in the first one, we didn't change anything with the second fraction, so it stays a 3. And the -1 times x squared is negative x squared. And then at this point, because all the denominators are the same, well, the equation is going to be equal as long as everything in the numerator is equal, and that's what we're going to solve from here. 4x plus 3 is equal to negative x squared. When we start to solve this, before we try to solve any further, we really just need to identify what type of equation it is. A lot of times people will solve or want to solve like it's a linear equation, and the way that we do that is you group all the x's on one side, everything else on the other, and eventually you're able to isolate the x. Well, we can't do that here because it's not a linear equation, and it has to do with the fact that we have an x squared and we have an x. Because they're not like terms, I'm never going to be able to combine those completely together. And this equation here is actually a quadratic equation, and there's different techniques in order to solve a quadratic equation. And the two most common would be, one would be factoring. You need to get 0 on one side and factor the other. And the other would be the quadratic equation, which still you need to get 0 on one side, and then you plug your other values into the quadratic equation. You rewrite our equation here, 4x plus 3 is equal to negative x squared. So if I was going to use either one of those methods, I'd want to get 0 on one side first, so I can start by adding x squared to both sides. And I can't combine any like terms on the left, so I'm just left with x squared plus 4x plus 3 is equal to 0. And at this point, if I were going to use the quadratic formula, well, the a value is 1, the b value is 4, and the c value is 3. I'm going to use factoring, though, because this equation factors pretty quickly. X, and we need two numbers that multiply to 3 and add to 4. And the only combination that works is plus 3 and plus 1. So x plus 1 times x plus 3, and then to finish solving, we set each factor equal to 0. And if we solve x plus 3 equals 0, we end up with x is equal to negative 3. When we solve x plus 1 is equal to 0, we end up with x is equal to negative 1. In this case, then, we get two solutions. One is x is equal to negative 3, and then the other is x is equal to negative 1. Just like with any equation, if I wanted to check my work, I would take those numbers and plug it back into our original equation, and I could verify because I'd end up with the same thing on each side that it is actually a solution.